Hello everyone, welcome back to the Atharva Academy. Myself Chinmay Dhadu. In previous video, we have discussed moment of area method to find out slope and deflection in the beam. Now in this video, we are going to discuss strain energy method to find slope and deflection in the beam. It is not very important topic because by using this method, we cannot find slope and deflection in all the loading condition. Here this strain energy method can be used for simple loading condition. Fine? We will see some simple examples based on strain energy method to find out slope and deflection. Now Castellanos theorem says that if U is the total strain energy of any member due to load P1 and P2 at point A1 A2 and moment M1 and M2 at point B1 and B2, then del U by del P gives deflection at that point, which is in the direction of force, and del U by del M gives slope at that point. Let's say we have this type of beam and here we have point A1, this point is point A2, this point is point B1 and this point is point B2, in which we are going to apply load P1 and P2 at point A1 and A2. So here at point A1 we will apply load P1, at point A2 we will apply load P2, and here you can see that we apply moment M1 and M2 at point B1 and B2. Means at point B1 we apply moment like this M1, and here we apply moment like this, that is M2. And let's say energy stored in this body due to these two loads and these two moments is U. Means total strain energy in this body is U due to this load P1 P2 and this moment M1 M2. Fine? So if this is the case, then what will be the then Castellanos theorem says that we can find out value of deflection at point A1 and A2, that is YA1 means deflection at point A1 is partial differentiation of strain energy with respect to P1, and it will give the value of deflection at point A1 in the direction of force. Means here there will be deflection of this point in this direction, means in the direction of this load P1. Fine? And if we will take del U by del P2 means partial differentiation of strain energy with respect to load P2, then we will get deflection at point A2. Means here we will get deflection of this point A2, and that will be in the direction of this load P2. Fine? Now understand that by using strain energy method we cannot find slope at point A1 and A2. Means here we cannot find theta A1 and theta A2. We can only find value of deflection where we apply point load. Now this Castellanos theorem says that if we take del U by del M1 means if we take partial differentiation of strain energy with respect to moment, then it will give slope at point B1, means we will get theta B1. And if we will take del U by del M2, then we will get slope at point B2. And here by using this strain energy method we cannot find deflection at point B1 and B2. Means here we cannot find Y B1 and Y B2. So understand that at point load we can find out deflection, and at concentrated moment we can find out slope. Fine? So from here you can remember this equation. Means Y is equal to del U by del P and theta is equal to del U by del M. You have to remember these two equations. Right? Now from this definition it is not very much clear that what is strain energy method and how to find slope and deflection. We will take one small example, then you will be able to understand that how to use this strain energy method to find out slope and deflection. Now let's say we have this simple Now we have discussed this example in chapter 5, that is strain energy. In this example, we have this cantilever beam of length L which is fixed at point B, and we apply point load P at point A. Here we found value of strain energy in this beam by this point load P. Fine, and it is P square L cube divided by 6EI. Now we are going to find value of deflection at point A, that is YA, by using strain energy method. According to the Castellanos theorem, del U by del P gives value of deflection at that point in the direction of load, right? So here we have to find del U by del P. Here we have value of strain energy, that is U is equal to P square L cube divided by 6EI. Fine. When we will take partial differentiation of strain energy with respect to P, then other terms will be constant. So it will be L cube divided by 6EI into del P square by del P. Fine. Here I take these terms as common. So now what will be the derivation of P square with respect to P? It will be 2P, right? So we can write that L cube divided by 6EI into 2P. Here this 2 will be cancelled and here it will be 3. So we have deflection at point A is equal to PL cube by 3EI. Fine. So I hope that you understand how to find value of deflection by using strain energy method. First of all, you have to find strain energy, and then you have to take partial differentiation of strain energy with respect to load. If strain energy is directly given to you, then you can go for this method. But if it is not given to you, then this method may be lengthy for you, right? So in that case, we can use other method. Fine. Now let's say we have this type of cantilever beam in which this point is point A and this point is point B. Here we apply concentrated moment M at this point in clockwise direction. Now what is the value of slope at this point due to this moment M that we are going to find by using strain energy method? Fine. Now we know that slope at point B is equal to del U by del M, right? So first of all we have to find strain energy. We know that this is the equation to find out value of strain energy in the case of bending load, right? Now in this equation we have to find mx, means moment as a function of x, and we have already discussed that in this case value of moment will be constant throughout length of this beam, means mx will be equal to m. So here we can write that u is equal to integration from 0 to L m square divided by 2EI with respect to x. So finally it will be equal to m square L divided by 2EI. Fine. Now we are going to find slope at point B. For that we have to take partial differentiation of strain energy with respect to m. So here we will take L, 2E and I as common. So it will be L divided by 2EI into del m square by del m. And here what will be the differentiation of this m square? It will be 2m, right? So we can write that L by 2EI into 2m. Here this 2 is cancelled, so we can write that slope at point B is equal to ml by E into I. Fine. So I hope that you understand how to use strain energy method to find out slope and deflection. In most of the case, we are not going to use this method. Mostly we will use double integration method to find out slope and deflection. And after this, we are going to remember the formula to find out slope and deflection in different cases. And by using that formula, you can quickly find value of slope and deflection in the beam. Fine? Now up to now, we have discussed that how to find slope and deflection in different types of beam under different loading condition by using double integration method, by using moment of area method, and by using strain energy method. Fine? But you can see that these methods are little bit lengthy, right? And in the GATE, we have limited time. So we have to solve questions of slope and deflection quickly, right? Means we don't have enough time to solve this whole example. So what we are going to do, we are going to remember these formulas. If you will remember this formula, then you will be able to quickly answer the question. And means your lots of time will be saved. Fine? Now see, here it depends on you that whether you want to remember these formulas or you want to go for method that we have discussed earlier. Anyway, here I am going to tell you the method to actually mug up these formulas, right? And actually I have learned this method from my faculty Rahul sir. So I am going to tell you that method here. Now in all these formulas, I have taken maximum value of slope and maximum value of deflection. In the case of cantilever beam, this beam is going to be deflect like this. So here maximum value of deflection will be here at this end and maximum value of slope will be at this end, right? So all this cantilever beam value of slope and deflection will be maximum at this end. And in the case of simply supported beam, if we apply this type of loading condition, then this beam is going to be deflected like this. So in this case, maximum value of deflection will be at midpoint of this beam. And maximum value of slope will be at end points of this beam. So here, this value of slope is slope at this end and this value of deflection is deflection at this point. Fine? Now first of all, you have to remember order of these beams. In first three cases, we have cantilever beam and in these three cases, we have simply supported beam. Now in first case, we apply concentrated moment at the end. In second case, we apply point load at the end. And in third case, we have applied uniform distributed load over this beam. Now here, we apply concentrated moment at the ends. Here we apply point load at the midpoint of this beam. And here we apply uniform distributed load over this beam. So actually it is easy to remember, right? First we apply moment, then we apply point load and then we apply uniform distributed load. And here it is same, right? Now we already know that how to find bending moment in these beams, right? So actually you don't have to remember these bending moment formulas. But if you want to remember this, then you can remember. Now we are going to remember formulas of slope and deflection. Now here you can see that in the denominator of all the formulas there is E into I. So it is common for slope and deflection. Now if we apply concentrated moment, then in slope there will be m into L and in deflection there will be m into L square. Means actually we are multiplying L from here to here and from here to here, right? And here also there is concentrated moment m, so in slope there is m into L and in deflection there is m into L square. Fine? Now if we apply point load, then in slope there will be p into L square and in deflection there will be pl cube. And similarly here there is point load at midpoint of this beam, so here in the slope there is p into L square and in the deflection there is p into L cube. And if we apply uniform distributed load W, then in the slope there is W into L cube and in deflection there is W into L raised to 4. Similarly in this case, here we apply uniform distributed load, so in the slope there is W into L cube and in the deflection there is W into L raised to 4. Fine? So actually you can see that power of L is increasing from bending moment to slope and from slope to deflection. Fine. Now we only have to remember these constants in denominator, right? So now we are going to remember this constant. For that we are going to use one trick. Now here I am going to use blue line for multiplication and black line for addition. You can use blue pen and black pen, or you can use one pen and one pencil. Now here this is the first formula and this is the second formula. So in first formula we will write 1 and in second formula we will write 2. Now how to get this 2? So this 1 into 2 is 2. So this blue arrow shows multiplication, means this 1 into 2 is 2. Now to get this 3 we will use addition. Here this 1 plus 2 is 3. Means here this black line shows addition. So first of all 1 into 2 is 2 and 1 plus 2 is 3. Now we will use again multiplication. Here this 2 into 3 is 6. Means we will get this constant. And now we will use addition. This 2 plus 6 is 8. So we will use this arrow, right? So actually we are using same pattern, right? First of all we have written 1 here and 2 here. Then 1 into 2 is 2 and 1 plus 2 is 3. 2 into 3 is 6 and 2 plus 6 is 8. So now we have remembered the equation for first 3 cases. In these first 3 cases we have one type of beam, and in these second 3 cases we have second type of beam. So here we are going to start with 2. In first case we have started with 1 and here we are going to start with 2. Now here how to get this 8? This 6 plus 2 is 8. So it will be like this arrow, right? 6 plus 2 is 8. Now from here it is little bit different to find out 16 and 48. For the 16 we have to multiply this 8 into 2, so we will get this 16. And for this 48 we have to multiply this 6 into 8, so we will get this 48. Fine. Now to get this 24 we are going to add 8 into 16, so it will be 24. So here it is shown by black line. And now to get this 384 we are going to multiply this 16 into 24. So it will be 384. And here there are 1, 2, 3, 4 and 5 cases above this formula. So here we are going to write 5. Right? So you can remember like that. Now here you can also remember the formulas of fixed beam. Means in this case beam is fixed from both the side. And in first case we apply point load at midpoint of this beam. And in second case we apply uniform distributed load over this beam. Now here you have to remember this moment, and you can remember formula of deflection. Here to remember formula of deflection, in this case you have to take YSS by 4. Here this YSS is deflection in simply supported beam. Means if there is point load in fixed beam, then we have to take deflection of simply supported beam under point load P, and you have to divide this by 4. So actually you have to divide this formula by 4 and you will get this deflection in this beam, which is under point load P at the midpoint of this beam. Fine. And to remember deflection in this case, you have to divide this formula by 5. So you will get deflection in this case. Here this YSS is deflection in simply supported beam under uniform distributed load over this beam. Fine. In most of the case, question is going to be asked from these 3 cases. And in these 3 cases, it is very easy to remember these formulas, right? It is following same pattern. Now see, to mug up these formulas, this trick may be not best for you, but I think this is best for me. So I use this trick to remember these formulas. Fine. And I know that if you will try this trick, then it will be also best for you. Actually, to remember this trick, you have to perform this trick 4 to 5 times in the rough book, and it will not take more than 15 minutes, right? So you can try this method in the rough work. And once you will remember these formulas, it will be very easy for you to solve questions to find out slope and deflection in these type of beams, right? Here I am going to tell you that how to perform this trick in your rough work. First of all, we will write 1 here and 2 here. Now this 1 into 2 is 2, 1 plus 2 is 3, 2 into 3 is 6, 2 plus 6 is 8. Now here we have to start with 2. So now it will be 6 plus 2 is equal to 8. Now 8 into 2 is 16 and 6 into 8 is 48. This 8 plus 16 will be 24 and this 16 into 24 will be 384, and there are 5 cases above this formula, so here we will write 5, right? So if you will perform this type of activity 4 to 5 times, then you will be able to easily remember these formulas. Fine? And if you don't want to remember these formulas, then we have methods to find out slope and deflection in the beams, right? So you can go for that method. So after watching this video, you can perform this activity 4 to 5 times and you can see that whether this trick works for you or not. And also tell me in the comment that whether it works for you or not. Fine? So today we will stop here and we will continue in the next video. Till then, stay motivated and happy practicing.